Hi, everyone, and thank you for joining our webinar. We're very excited that you could join us today to discuss a topic that is seldom discussed in the hotel business, but it's starting to become much, much more important, which is the mathematical side of revenue optimization, and for that matter, any kind of optimization. Between our two sessions, we have almost 200 participants, so we have a lot to cover, so let's get started. My name is Robert Hernandez, and I am the Chief Data Scientist here at Origin World Labs. My job essentially is to build revenue management models so that properties can make more mathematical decisions about the rate choices that they make, about the controls that they place on certain type of segments. Essentially, it's their models to analyze the entire RM process. I also build guest behavioral models, which allow you to be able to analyze smaller segments of your transient guests. And I also do micro segmentation, which is where you basically help marketing pinpoint one-to-one relationships with each customer. You can email me anytime you want at robert@originworld.com with any questions about this seminar or about any other issues in revenue management that you'd like to discuss. The motivation behind this seminar is pretty simple. A lot less than 1% of hotel professionals involved in some kind of pricing decision actually have the mathematics background required to be able to make those decisions in an informed and scientific way. The vast majority of revenue managers in the hotel industry are not required to have a math background, and that's why the hotel industry is the only industry where revenue managers don't typically have any kind of mathematics, economics, or engineering backgrounds. In all the other industries, including airlines, cruise lines, and other travel-related industries, you are required to have an operations research or mathematics background. Now, it's obvious that there is a lot less cruise lines than there are hotels, but what that means, though, is that potentially, if we are not analyzing our RM issues mathematically, there's a lot of value that we could be leaving on the table. And the motivation behind this webinar is to try to get people thinking a lot more in terms of mathematical analysis of revenue management issues. And what we don't want, though, is for people to run RMS systems or any kind of models or pricing systems and not understand the algorithms that run these systems, because most of them, to be honest, are kept secret. We don't believe that that's actually beneficial for the industry. Revenue managers should actually be able to understand the way the systems are thinking, how these algorithms are functioning, so they could actually use the systems a lot more effectively. Now, every time you see a light bulb at the top left-hand corner of a slide, pay attention to that, because that is information that will put you at the top 1% of knowledge in the hotel industry. Again, most people that are in the RM profession will probably not know the information that you are looking at in that slide, and that's why it's important for you to pay particular attention to it. So let's jump right into it. What is optimization? Well, essentially, optimization is the selection of a best solution among many different alternatives. And whatever that best alternative is, really depends on what you're trying to optimize. And the classic example in the hotel business is brand optimization versus revenue optimization. There's always a battle going on between marketing and revenue management as to what revenue management wants to do, potentially drop the prices in order to increase revenue, versus what marketing or the branding people want to do, which is essentially to try to keep the brand perception as high as possible by not really discounting too much or deteriorating the brand through wide or indiscriminate proportions. So optimization really depends on what it is that you're trying to optimize, although in this webinar we're going to concentrate on just trying to optimize the revenue, irregardless of whatever other issues it might cause. So over the last 3 decades or so, there's basically 2 types of optimization algorithms or approaches that have been used in the hotel business and have been built in most of the popular RMS. The most popular, or the one that came first, is capacity control, which is the one on top. And that is basically inherited from the airline business, whereby you define certain rate classes and then you close off those rate classes as you fill the classes to the capacity that you assigned it. So basically, the revenue manager decides on the rate that they're going to offer for each class. And as soon as the inventory that they have assigned for that rate class is filled, they close off that rate class and move on to what we call a higher rate class, which is a rate class that has a lot more value. So in a nutshell, capacity control is the process of using inventory to try to stop guests from booking certain rates, and therefore that's how you control how many people you allow to book your hotel. Now, the second algorithm is called dynamic pricing, and that's actually the one that we're going to concentrate on in this webinar. And the way dynamic pricing works is that first you build some kind of algorithm or model to search through your data so that it comes back and suggests the rates that you should be thinking about, or maybe the rate range that you should be thinking about offering. And then the revenue manager kind of evaluates that information versus what they know about the market or something that the model might not know. And then you offer a sell rate. And then you see how that sell rate reacts, or how the demand reacts to that sell rate. So essentially what you're doing with dynamic pricing is that you're controlling the booking pattern of your hotel by moving your prices up and down, not necessarily by closing off inventory as in capacity control. So if you offer higher prices, what you're trying to do is prevent people from booking your hotel because you really don't have that many rooms to sell. And if you're offering lower prices, what you're trying to do is motivate people to book your hotel because you have a lot of inventory to sell. And that's the algorithm that we're going to be concentrating on today, which is, again, dynamic pricing. Now, how do we start the process? Well, what we have to do is create some kind of mathematical representation of how our guests react to our decisions. And our decisions are the rates that we set. So we need some way of being able to predict when we set a certain rate, what's going to be the reaction in the market, or what's going to be the reaction from the guests that are booking our rooms. And this is called a model. It's a representation of some kind of economic phenomena, again, which in this case is the process of booking. Now, the way that we are going to model the way that potential guests react to the pricing decisions that we make is with something called a demand curve. Now, don't think that we're going to make an actual curve, although in more advanced RM analysis, you do actually build curves. The word curve comes from economics. What we're actually going to be building is a line. And the reason for that is because we're going to try to keep this exercise as simple as possible, because we are learning here the concepts of mathematical optimization, not necessarily diving 100 feet deep into it. We're just trying to get a grasp of how it is that this process works. So again, what we're trying to build is some kind of model that helps us estimate how the guest demand changes when we change our rates. One thing we definitely want to keep in mind is that even though we're going to come up with an optimal solution to a very specific problem in this webinar, you can always be more optimized. So optimization never really ends, because you can always dig deeper and dig deeper into data to build demand curves that get you a lot closer to each individual guest. And everyone has a different demand curve for different products depending on the time that you're going to purchase it. For example, a Christmas tree for me in January is pretty much worthless. So I have zero demand curve, or my demand curve for that is basically non-existent. But during December, that Christmas tree becomes very valuable. So I definitely do have a range of prices that I'm willing to spend. And, depending on if it gets too expensive, I might not be willing to buy a tree, or if it gets cheaper, I might be willing to buy it right away. So everybody has a demand curve depending on the time that you approach them, and also depending on who they are and what kind of guest they typically behave as. Okay, we're going to try to keep our exercise, again, as simple as possible, so we could really explore the concepts instead of worrying too much about what the issues with the particular property are. Although in real life, we know that it's all about the particular issues with the real property, and that's why you really need to explore revenue management at the property level. But anyway, let's assume that we have a hotel that is 70 rooms, and there's only one room type for the entire property. And all guests are pretty much the same, except that you have transients and you have groups. Now, throughout the year, we charge different rates, depending on what time of the year it is, and also depending on the discounts that certain guests are offered, or some promotions and marketing by me running. So we have a varying amount types of rates. Again, we also have group business. But for us, all the weekdays are pretty much the same. There isn't kind of that shoulder of Thursday and Sunday. All the weekdays behave the same, and the year-over-year demand hasn't really changed, which will complicate this problem if we start thinking that maybe 3 years ago was a lot weaker than this year. That's going to complicate the issue. So let's assume that all the last few years were all the same, and we only have one channel that we're selling through. Because of course, we have rate parity issues and all that in the real world, and we have to clean this problem up in order for it to make sense. So let's just assume we have one sales channel. So assume that we just came to this hotel as a brand new revenue manager, and our first assignment is to try to figure out what we're going to charge for weekdays in August. So we pull some information from our PMS system, and we have data over several years. And what we've done is we've divided basically the pricing into two different types of groups that we've seen. There's definitely a type of pricing that the hotel charges when they have groups, and there's a type of pricing that they charge when they don't have any groups. And essentially the average rate that you've seen the hotel charge is about $150 during the weekdays in August when they don't have groups, and about $350 when they do have groups. And of course, there's been a different average pickup for Sunday through Thursday, depending on whether the rate was low or the rate was high. But in the end, the average pickup when there was no groups was about 60 rooms sold. And with groups, you sold about 10 rooms based on that price of $350. Now, here's a problem that it's kind of a side note, but here's a problem with averages. You notice that our average is 60 and 10, but yet there's not a single day during the week on average where you sold actually 60 rooms, and there's not a single day on average with groups that you actually sold 10 rooms. So again, playing with averages is a problem, but we're trying to simplify this problem. We're not going to worry too much about what the deviations are from this average. Right now, we're just trying to focus in on the mathematical model that we're trying to build. Now I have a high and low point to play with, and if I present that graphically, you can see on this chart that at the $150 point, you sold 60 rooms, and at $350, you sold an average of 10. So what we want to do is we want to find the line in between those 2 points, so then we can estimate what the pickup will be for any of the rates that are either lower than the 150 or higher than 350, or any of the rates in between. Once we have that line, we could build actually a mathematical formula that will allow us to estimate any of the points on that line. Now, you should have already read the pre-session handout where everything that I'm about to cover is detailed. The function that we want to use is the function for a line, and that's going to be basically our demand curve. We're going to estimate the components of this function for a line, which is going to be obviously the components for our demand curve. So what we want to be able to do is insert a rate into this function for a line and get as a result, be able to find out what the rooms sold are at that rate. So for that, we need to estimate a slope and an intercept. And the way that you estimate the slope is that you get the highest point and the lowest point, and you subtract their x and their y's. So we take the lowest amount of rooms that were sold and subtract the highest amount of rooms that were sold, and then we kind of do the opposite at the bottom, which is take the highest rate where those highest rooms were sold and subtract the lowest rate where the lowest room were sold, and that gives us our slope, which in this case is negative 0.25. Now, your slope should always be negative. There should always be a negative slope on the demand curve, because as you increase the rate, the amount of rooms that you sell should go down. So it's a negative sloping curve. And essentially that slope is basically giving you an index of how demand is affected by price. In and of itself, the slope doesn't really mean anything, but you can compare the slope of one demand curve to another demand curve to try to figure out which one has a lot more elasticity. We're not going to discuss elasticity here, but it does build into that. Okay, so now we take that slope and we stick it back into the formula up top, and then we use 2 points, any of the 2 points that we had originally. In this case, what I'm going to do is use the highest price and use the rooms that were sold at the highest price, and then I'm going to solve for the intercept. And when I solve for the intercept by actually multiplying negative 0.25 times 350 and then bringing the total as a number to the other side where the 10 is, I get that the intercept equals 97.5. And in general, or in a very simplified way, that essentially just means that if I were to sell my rooms at a rate of 0, that is the number of rooms that I'd be able to sell. Now that's ridiculous for two reasons. One is we don't have 97.5 rooms, and the other one is that at 0, I'd probably be able to sell 1,000 rooms, not 97.5. So again, we're trying to keep the problem simple, and since that scenario is not going to happen anyway, we're going to go ahead and say that the 97.5 is a good estimate of the intercept for this line. Now that we have a demand curve, we can go ahead and start plugging in rates and seeing what kind of rooms sold we get for each rate. And what I've done here is that I've taken increments of 50 and started from $50 all the way to $400. And we see that the rooms sold quickly go down as you increase the rate. And on the right-hand side, we have the graphical representation of the demand curve, which is essentially plugging in as many of these rates and then drawing a line from one point to the other. So, as we see, which is very important, that the 350 rate does give us 10 on this curve, and the 150 rate does give us 60. So in fact, this demand curve does accurately estimate the original demand curve that we started off with. So we have essentially now built a model, a mathematical representation of how the potential guests react to our price changes. And we're now can use this model to be able to find the optimal point where a rate times a room sold gives us the most revenue. Now, with just one point, you see that at the rate of 400, there is a negative number. Remember, the lines go infinitely, so I could essentially plug in any number for the rate, 1,000, 2,000, or whatever. If I get a negative number, it doesn't mean that you're going to sell negative rooms. It just means that you've reached 0 and there's no more rooms to be able to sell. In other words, that rate is almost impossible for you to charge. So now let's figure out where the optimal revenue is. And for that, we have to figure out what are all the different possibilities of revenue that we can have. If we take the rates from the previous slide and the rooms sold that we calculated using our demand curve, we have a different scenarios for the revenue. And we see that at 9,500, the revenue is optimized. Any lower than that in rate, you won't sell enough rooms, and therefore the revenue is too low. But if you increase the rate, then the rooms that you will sell will be even less. So then the rooms will the revenue would also be suboptimal. So at $200, if you only had to pick one rate for the weekdays in August, $200 would be the best rate to pick. You'd sell about 48 rooms and you'd optimize your revenue. So that's figuring out the revenue optimization the easy way. Now let's try to do it the math way. So if we're trying to estimate the optimal rate for 365 days, that approach that we took in the last few slides was incredibly inefficient, and we'd be doing that all day. And by the time we finish, we'd have to start all over because it would be the next day, and now we have a new set of variables. So luckily, we have the mathematics of algebra and calculus to help us. And the first thing we're going to do is that we're going to take our demand curve and from it create a revenue curve. So essentially, revenue is just the rate times the number of rooms sold. And now we have what the number of rooms sold equals, which comes from our demand curve. So we're just going to replace that into the revenue formula and come up with a new formula where revenue equals the rate times everything that's inside the parentheses, which essentially comes from the first formula on the slide, which is the demand curve. Now, using the distributive property, and you could, again, this information is covered in our pre-session handout, you are able to build a brand new revenue curve where you can actually plug in a rate and it will tell you immediately what the revenue is. And that revenue curve is here at the bottom. After you use a distributive property to multiply the rate into what's in the parentheses and essentially bring those numbers out, you get that the revenue curve is that slope times the rate squared plus the intercept times the rate. So now this is very useful because there's a couple of things that we could do with it. So now if you take all the points at the bottom of this graph, which are essentially the prices that we've been playing with all along, and you go ahead and introduce them into that revenue curve function, you get the revenue points that are on the left-hand side, and if you draw a line across all those points, you will get a curve. And now this curve is very interesting because there is a point somewhere around the price of 200 where this curve tops out. And essentially what's happening is on the left-hand side of this curve, the more you're increasing the rate, you see that the revenue is going up. And on the right-hand side of sort of that middle point, the more you increase the rate, the revenue is actually going down, so the total revenue is decreasing. So what we want to find mathematically, which is what we did before manually, is we're going to try to figure out where this curve tops out, or in fact the increase and the decrease is zero. There is no more increase and is no more decrease. And for that, we need the mathematics of calculus. So the mathematical way of figuring out the optimal revenue is to take our new revenue curve, which we see here at the top, and this is again explained further in the pre-session handout. But we're going to find the derivative of the revenue curve, and that new function that we get, that new formula, is essentially a formula that tells us for any rate, are we on that left-hand side where the revenue is going up, or are we on the right-hand side where the revenue is going down? And we're not going to go into the process of how to find the derivative. That's in the pre-session handout because we just don't have enough time here. But just be aware that the derivative gives us the changes that are going on within the curve. The derivative of a revenue curve graph is very interesting because it tells us exactly visually where that optimal point is. And as you see, at the $200 point or somewhere close to that, we crossed the zero line, which is where the x-axis crosses the y-axis at zero. So that tells us that around that point, we can expect that we are at the top of that revenue curve, and we're not even, we're not getting more positive or getting more negative. So how do we use then that fact in order to find what the optimal rate is with the derivative of the revenue curve? Well, essentially just set the entire function to zero and then solve for the rate. So if we do that and bring the 97.5 over to the zero and divide by the negative 0.5 to get rid of that negative 0.5 from the optimal, from the rate side, you will get that the optimal rate equals $195. So at $195, this function becomes optimal. In other words, the combination of rates and the number of rooms sold that you're going to have based on the rate becomes completely optimized at $195. And this is why it's better to use mathematics than to do it manually, because even though I used ranges of $50, I could have used ranges of $75 or maybe even $100. And if I would have done that, I would have gotten very different answers. Only the mathematical way can you come up with what the exact point is on the demand curve that you've estimated of what the optimal rate is. So that's why the mathematical way is always a lot more efficient. So now how do we figure out how many rooms you're going to sell at the $195? Well, let's plug that back into the demand curve that we built before, and you get that you're going to sell an optimal room, which is the number of rooms that you're going to sell using the optimal rate of 48.75, which is almost 49. And what's the revenue that you can expect to get at 49? Well, that's just $195 times the 49 rooms, and that equals $9,555. So if you choose that optimal rate, there is a very good likelihood, based on the data that we collected before, that you are going to be able to make around $9,500 per every single day in August, for every single weekday where you set that price. Again, based on the data that we collected before. But now we have different markets in this hotel. So what if the group salespeople book around 30 rooms and we only have 70? So now we only have 40 rooms left. And we know that the optimal rooms that we want to sell is 49 in order to optimize the revenue. Well, now we're going to have to go back and readjust our prices in order to be able to just sell 40 rooms. A price that's too low is going to oversell the hotel, and a price that's too high is not going to give us an optimal revenue. So what is the new optimal rate? Well, we need to go back and resolve our demand curve for the rate instead of the room sold. And if you do that algebraically, you bring everything over to the room roll side, you get that the rate is going to be equal the room sold minus the intercept, which is 97.5 divided by the slope. And if you plug in the number of rooms sold, which is now 40, it's the quantity of rooms that you have left to sell, you will get that your new optimal rate is $230. So now you have to increase your prices by $30 in order to dissuade a certain amount of demand so that you don't oversell and you only sell the 40 rooms that you have, and also at the same time you optimize your revenue. So that in a nutshell is dynamic pricing, and it is the way that you can figure out how to optimize your revenue using the data in your PMS system. Now, obviously, as a revenue manager or as a person that sets pricing, you have the final say, and you can also bring into the calculation certain types of variables that we never discussed in just a pure mathematical approach. But at least you have a guide that tells you kind of what the range should be, or what would be kind of the logical choice to make based on the demand patterns that you can extract from your PMS system. And now, what you want to do with this type of mathematics is go deeper and deeper and deeper in creating demand curves that are a lot more segmented, because the total hotel demand curve is really not that useful, because every day is different, and we have events and citywides, and we have very different room types, and we also have very different sources, and each of those has a different demand curve. And ultimately, even the behavior of the guests can be analyzed in order to figure out what are the different demand curves that we should be assigning to each of these elements of the hotel demand. And again, all this information is inside your PMS system. It's just a matter of extracting it and organizing it in the way that we did in this webinar, so that you can get enough demand curves to be able to estimate those optimal rates. So we're almost at the half-hour mark. So that essentially concludes our presentation on the mathematical side of revenue optimization for hotels. What I encourage you to do is take some of the information that you learned in this webinar and go try it out on your own data and kind of make mistakes with it and go back and forth and see what kind of answers you get for your own particular hotel. Again, there's no one watching this webinar where there's going to have the same exact data, because all hotels are different. And if you're interested in what you saw and you want to dig deeper into it, we strongly encourage you to take the courses that we have online on the science of hotel revenue optimization, and you'll actually get a certificate at the end of it. We have hundreds of hotel revenue managers, general managers, marketing and finance people that have already earned this certificate throughout the world, and the feedback that we get from them is that it totally changes their approach to pricing and revenue management, because now they understand how to get the data, how to extract it, how to look at it in a way that they couldn't before, without having to depend on any system from a software vendor, and also to be able to take that information and get new insights from it that they weren't even thinking about before. So again, take a look at the video that's below this video on this page, and you will learn more about the certificate, and it will totally transform the way that you approach your job and also your career path. Thank you very much, and we hope to see you at our next presentation.